Myself, Dr. Babu, currently working as an assistant professor in the Department of Electrical and Electronics Engineering at the University of Surampalem. Today we are going to discuss about three-phase circuits. In that three-phase circuits, we are dealing with module 3. In that module 3 also we are mainly concentrating on loop method for the analysis of three-phase unbalanced loads for a three-phase three-wire system. Now we are mainly in this lecture, we are going to focus on loop method. Okay, coming to loop method, here is the circuit diagram for the loop method. Here we are, as I told earlier, this is a three-phase three-wire system. So three-phase three-wire system may be star or delta, but for delta the connections and equation part is different, and we are going to deal with mainly our star connections. So here is the star connections. It consists of three-phase R phase, Y phase, and B phase, and IR is the line current flowing through R phase. Similarly, IY and IB are the line currents flowing through the Y and B phase respectively. In a similar manner, the ZR is the impedance across R phase, ZY and ZB are the impedances across Y and B phases. Now, as the method states, a loop method or mesh analysis method, we are supposed to draw a loop. Okay, and one more thing, this VRY is the voltage across R and Y phase, and VRB is the voltage across R and B phase, and VYB is the voltage across Y and B phase. So in star connections, okay, line current is equal to phase current, whereas voltages, line voltage is equal to root 3 times of phase voltage. That means if we attain or calculated one current value, both the current, that means the currents in line and phase are equal, but the voltage value will be different. So we need to calculate the voltage values separately. So as per this method, so as per this loop method, loop analysis method, here we are drawing a loop. So here if you observe, this means here we have drawn a loop across R and Y phases and another loop at Y and B phases. Okay, that means here we have drawn two loops. Now you people may be having a doubt, why R hasn't drawn a loop across R and B also. Yes, we can draw a loop across R and B also, but this loop method, here see, this IR is equal to I1 directly, okay, and more or less this I2 is equal to IB. That means two constant values we are getting, and this one means it may be in the form of I1 minus I2 or I2 minus I1. Okay, so for that purpose, in order to reduce the complexity and to gain a simpler manner, we are eliminating this part. Okay, or else you can eliminate this path and you can use this path, or else it's up to your choice. So, but it's up to you. But here I am concentrating on these two paths only. Okay. So this one path I am concentrating, and this two path I am concentrating. See here now. This, if I take VRY as the reference, the VRY value will be VRY at an angle of 0, and VRB value is VRY at an angle of minus 120, and VYB value will be VRY at an angle of minus 240 degrees. Okay. Now I am going to write the KCL equations across this loop 1 and this loop 2. Okay, see here, if I have taken VRY as the reference, okay, see, VRY is equal to, see here, this I1 current into ZR, okay, I1 current into ZR plus, see here, this I1 current is entering at this point and this is leaving, I2 current is leaving at this point. So that's why I1 minus I2 into ZY. Okay, so this is the KVL equation at loop 1. Now I am going to write the KVL equation at loop 2. That means this part. Now here the voltage is the source, so that's why VYB, I have written it outside. VYB is equal to, now see, this part. Because here I have taken I2 as reference, I am erasing this part and I am keeping this part. See here, now the current is entering, I2 current is entering at this point, so that's why I2, and I1 current is leaving at this point. So I2 minus I1 into ZY plus I2 into ZB. So I have drawn the two KVL equations for this, and these two KVL equations are shown here. Here they have given a phase difference of at an angle 30 degrees and minus 90 degrees, because both should be having an angle of 120 degrees phase. So for that purpose, an angle of 30 degrees and minus 90 degrees have considered over here. And also the loop currents are I1 and I2. Now if you compare the loop currents with the line currents, see this part. Okay, see the across this part. This I1 direction and IR direction is same. That see, I1 direction and IR directions are the same. That means I1 is equal to IR. Okay. Now I am going at the junction of loop 2. Now if you observe these directions, IB is in opposite direction. That means the current flowing through this ZB is in opposite direction and the I2 is in opposite direction. That means this I2 is equal to minus of IB, you can write it. Am I clear? See here, the current directions are both in opposite directions. So that's why the I2 is equal to minus of IB. And the third current, that means this current flowing through this ZY, it will be the combination of I1 minus I2. Okay, is it clear? Now I am going to write the phase voltages. This is VRN, right? VRN is equal to the current flowing through it is IR and the voltage across it is, impedance across it is ZRN. In a similar manner, if I am going to write the voltage equation across biphase, V by N is equal to the current flowing through it is IY and the impedance across it is ZY. Okay. In a similar manner, if the voltage across B phase is VBN is equal to IB into ZB. Okay. This is very far and very simpler method because here we are going to write only two KVL equations, and with the help of these two KVL equations, we are going to solve the numericals and all the things. So now we will be going to solve a numerical by the help of this method. Okay. Now you can observe this, the numerical. See, here they have given 440 volt supply and this is a 3-phase. They have mentioned it as 3-phase, 3-wire. Okay. The branch impedance are ZRN they have given, ZYN they have given, ZBN they have given, and they have asked us to find the line currents by mesh current analysis. If they have asked you to find a particular method, you should solve the numerical with the help of that particular method only, or else you can solve with the help of conventional one only. So here it is a star connection load. So for that purpose, I am drawing the star connected load over here. So this is R phase, this is Y phase, this is B phase, and this is the neutral point. This value is ZRN is 10 ohms and ZYN is 15 ohms and ZBN is 20 ohms. And here the value of voltage is 440 volts. 440 volts. Okay. Now see here, with the help of loop analysis, now let us write these values also. The current flowing through it is IR, and here the current flowing through it is IY, and here the current flowing through it is IB, and this part ohm, and in this loop it is I1 and in this loop it is I2. So in the previous case we have written some KVL equations. I think you people have remembered it. Now I am rewriting those KVL equations over here. 440 at an angle of 30 degrees is equal to I1 into 10 plus, in this one current is entering and leaving, so I1 minus I2 into this one ZY is 15 ohms. Now I am writing for this loop 2. This is for loop 1 and this is for loop 2. Now for this it will be 440 at an angle of minus 90 degrees is equal to first one I2 minus I1 into 15 plus this one I2 into 20. So with the help of calculators you can solve these values. Okay. So with the help of scientific calculators only we will be solving these things and we will be getting the values of I1 and I2. Okay. Now the line currents you have obtained, where I1 is equal to current through phase R and I2 is equal to minus of IB, because see here I2 is equal to both currents in opposite, so I2 is equal to minus of IB and current through Y phase is I1 minus I2. Okay, this part I1 minus I2. So we have attained the values of line currents. Okay, so here in this numerical we have solved the values of line currents. Line currents are nothing but line currents is equal to phase currents in star connection. And apart from that, okay, we need to calculate the values of line voltages and phase voltages. That means in extension to this numerical we are going for calculation of line voltage and phase voltages. So for this I am deleting this part. Sorry. Okay, let's start by the calculation of line. First we will be going to the calculation of phase voltages. Phase voltages. Now first phase is VRN. Therefore VRN is given by IR into ZR. Okay. But we know that from the previous section I1 is equal to IR. So from that we got the value of IR and the ZR value it is already given the numerical, and write it, calculate it and write down the values. And in a similar manner in the next case VBN. VBN is equal to, that means this phase. The current flowing through this VBN phase is IB and the impedance across it is ZB. From the new in the previous that means in the previous one we have got the I2 is equal to minus of IB. Write down that value and write down the value of ZB value here, calculate it and write down the value phase value of VBN. And next one is VYN. So for the VY1 the value of current flowing through it is IY into ZY, but the value of IY is I1 minus I2. Okay, because from this diagram it will be I1 minus I2 and the ZY value is 15 ohms. Okay, now we have got the values, calculated the values of phase voltage, that is VRY, VBN and VYN, and after that we need to calculate the values of line voltages, and we all know that line voltages is root 3 times of phase voltage. Okay, so with this, like this we can calculate the values of line voltages. So in the given numerical they have given only impedances and supply voltage. From that, with the help of loop or mesh analysis method, we have calculated the values of line currents and phase currents, both are same. After that we have calculated the values of line voltages and phase voltages. After the calculation of this line voltage and phase voltages, we need to calculate the values of power. Okay, power across R phase is equal to VR phase into IR phase into cos of angle between VR comma IR. Okay, here you got the value of IR and VRN is already given here, and the angle also will be getting. Write down the power value of R phase. In a similar manner, calculate the power across Y phase. VB, VY, IY, cos of angle between VY comma IY. In a similar manner, power across B phase. VB, IB, cos of VB comma IB. Now we have calculated with the help of this formula, we have calculated the power in the phases R phase, Y phase and B phase. Now in the numerical they have asked you to calculate the value of total power, that means capital P, which is the combination of PR plus Py plus Pb. So this is the procedure for the calculation of total powers. Now coming to the summary of our today's session, we have gone through the loop analysis method, which we have applied, which we got the values by applying Kirchhoff's voltage laws. And the applications are, we can simply apply this for complex circuits and analyze the values of voltages, currents and impedances. And the main application is to design and optimize the electrical circuits. Okay.